All right, folks, it's Fast Action, back in action here. In this video, we are going to work with the area formulas for kites and rhombi. It's going to be the same formula. We're also going to look at all the various properties of kites and rhombis, and just like we did in the previous video, how we can use them to fill in whole bunches of information about our kites and rhombi. Okay, so let's jump in here with this first one. That's going to be our rhombus right here. And the first thing that we're going to do is just start filling in little bits that we know. We know that if this is a rhombus, all four sides of this are going to be congruent. So each of these sides is going to be a 10 radical 6. So we, of course, can fill that in. That means that we immediately know that the perimeter of this rhombus is 40 radical 6. So you might as well fill that in right away. We know that the diagonals are going to bisect each other, so we're going to have a 17 and we're going to have a 17. But unlike in our rectangle where the diagonals are congruent, these diagonals are not congruent, but they are going to be perpendicular. We can use this 50 degrees here to recognize that all four of these angles are going to be congruent, so we're going to fill in our 50 on all four of these. And then, of course, since we filled in this right angle, we've got this nice right triangle, so that means that we automatically know that this angle here is 40, and of course all of these are going to be 40 because all four angles in the corners of a rhombus are congruent. So you can see we've already filled in a lot of information. Now, if we want to find the area of this rhombus, we're going to fill in this area formula up here. So our area formula is 1/2 diagonal 1 times diagonal 2. So we're going to need the lengths of both of these diagonals. Currently, we only have the length of the one diagonal here. That's going to be 34. We need to know this piece. In order to get that piece, we're going to look at just any one of these triangles. All four of them are going to be congruent on our rhombus. And since it's a right triangle, we can do a really easy Pythagorean theorem on this. So we're going to do our Pythagorean theorem. This is our right angle, so this is going to be our hypotenuse. So we're going to have our 10 radical 6 squared, and that's going to equal our 17 squared, plus I'm going to call this piece x, our x squared. Remember, when we square our radical, that's going to give us 100 times 6, and that's going to give us a 600. So we're going to have our 600 minus our 17 squared is going to give us that last little piece is going to be the square root of 311. Now that's going to be both of them. So when we find the area of this rhombus, we're going to have 1/2. This diagonal that we knew was 34. And this other entire diagonal, that is going to be a 2 square root of 311. Multiplying these, I can see the 1/2 and this 2 are going to cancel. So my final answer on this is going to be 34 square root of 311. So it's not a super attractive answer, but it'll work. Okay, so there's going to be our area. Now let's move on to our kite over here. Little reminder on our kites. We're going to have two pairs of consecutive congruent sides. The opposite sides cannot be congruent, otherwise it's going to end up being a parallelogram. So if this is 5, this is 5. And if this one's 11, then this one's 11, which means we can very easily get our perimeter as our 5 plus our 5 and our 11 and our 11. So our perimeter is going to be 32 centimeters. Didn't really have to do much work for that. Then we can go ahead and recognize that just like in a rhombus, the diagonals in a kite are going to be perpendicular, so we can go ahead and fill in that nice right angle there. That right angle is, of course, going to give us some triangles where we can do some Pythagorean theorem. Let's also fill in some of our angles. If you can look at your kite as two isosceles triangles, so I have an isosceles triangle here, which helps you remember that this angle right here is going to be 37 degrees. The opposite angles, they're called the non-vertex angles, are going to be congruent. So looking at this triangle here, I have a 37, a right angle, and I can fill in this angle here of 53 degrees. So if this is 53 and this is 74, then this whole angle over here is going to have to match. So we can fill it in pieces, or we can fill in the entire thing. Either one that you want to do. I'm going to write the two pieces separately. Of course, that also means we can fill in these angles down here, these other vertex angles. They're talking about the vertex of these isosceles triangles. I have a 74, I have a right angle, so I could fill in the remaining angle down there. So we're going to write that one in. And that gets us all the angles in the kite. Now, in order to find the area, again, let's go back. Let's think we need to know these two diagonals. And you'll notice that we don't have any of the parts of our diagonals right now. So what we're going to do is we're going to work with these outside pieces. I have a 3 and I have an 11, which means I can get to this piece right here doing my Pythagorean theorem. So I'm going to have my 11 squared, my 3 squared. I'm going to call this little piece x squared. That's going to get me, that piece is going to be a square root of 112. That, when I clean it up, is going to be 4 square root of 7. Okay, so it's not going to be pretty, but it'll work. Now, this is going to be the base of an isosceles triangle, so it's bisected, so that means that this piece right here is also going to be a 3. Now, if this is a 3 and this is a 5, I have another nice right triangle here, and this one is in fact one of our little triples, our 3, our 5. This piece has to be 4. You could, of course, write out your Pythagorean theorem, but it would be good if you could start to recognize that Pythagorean triple. Now we're ready to do our area. So our area is going to be 1/2. We know this diagonal right here is 6. And then our other diagonal is going to be a little unique because these are not like terms. Our 4 and our 4 radical 7 are not like terms. So we're going to keep those separate. We're going to write 4 plus 4 radical 7. Those are not like terms. This, of course, can become a 3. And then we're going to distribute our 3, and we will get our area of 12 plus 12 radical 7. So it looks kind of strange, but we want to get comfortable with those types of areas because we're going to see them as we progress throughout the remainder of the semester.